Deep in the sandstone cliffs of the American Southwest, entire villages clung to sheer rock faces. Yet the real secret of their survival was not the walls, but the invisible veins of water they coaxed from the desert. Around 750 CE, the Pueblo builders began carving stone basins into the canyon floor, creating a network of reservoirs that could hold up to 40,000 gallons each. They lined the interiors with a thick layer of locally sourced clay, then tamped it down with wooden paddles to make it watertight. Rainfall in the Four Corners region averages just 12 inches per year, but a single summer storm can dump a foot of water across a 10-acre catchment, filling a reservoir in a matter of hours. The water was channeled through narrow stone sluices that slowed flow, allowing sediment to settle before reaching the storage basin. Seasonal overflow was directed into secondary cisterns, creating a cascade system that maximized capture while preventing erosion. Archaeologists have measured the remaining walls and estimate that the combined capacity of the Mesa Verde reservoir complex could sustain 200 people for an entire dry season, a feat that modern engineers still study for its efficiency. Cliff Palace, the largest cliff dwelling at Mesa Verde, housed 150 rooms and 21 kivas, but its lifeblood ran through a hidden plumbing network. Builders cut shallow channels into the sandstone cliff face, directing runoff from the roof of the overhanging ledge into a series of stone-lined troughs. These troughs fed a central cistern carved directly into the cliff, measuring roughly 12 feet long, 8 feet wide, and 6 feet deep, enough to store about 30,000 gallons. The Puebloans installed wooden spillways that could be raised or lowered with simple lever systems, allowing them to regulate water flow during heavy rains and conserve it during droughts. Inside the dwelling, small clay pots were placed in the walls to absorb humidity, creating a passive cooling system that reduced evaporation by up to 15%. Radiocarbon dating of organic material in the cistern walls shows continuous maintenance for over 4 centuries, indicating a sophisticated understanding of both construction and long-term water management. Further north, the Chacoan people engineered an extensive canal system that rivaled Roman aqueducts in scale. Stone-cut gates, some weighing over 2 tons, controlled the flow from natural springs such as the nearby Gallo Spring. From these gates, a series of limestone-lined canals stretched up to 3 miles, delivering water to the great houses of Pueblo Bonito and Chetroquetl. The canals were graded at a precise 0.2% slope, ensuring a steady, laminar flow that minimized loss. At strategic points, the water was diverted into rectangular catch basins, each holding roughly 5,000 gallons, which were then used to irrigate terraced fields on the canyon floor. Soil analyses reveal that the fields produced maize yields up to 30% higher than nearby rain-fed plots. The entire network required coordinated labor. Estimates suggest that a team of 30 workers could excavate 10 feet of canal per day using stone hammers and wooden levers, a testament to communal engineering prowess. The Mug House Cliff Dwelling, perched on Wetherell Mesa, showcases perhaps the most refined cistern ever uncovered. Carved into a natural notch in the cliff, the cistern measures 9 feet by 7 feet with a depth of 5 feet, yielding a capacity of about 22,000 gallons. Its interior was coated with a mixture of powdered gypsum and river sand, creating a waterproof plaster that has survived for 8 centuries. Researchers observed a narrow inlet notch that acted like a siphon, allowing water to enter only when the external water level rose above a specific threshold, thus preventing overflow. Inside, a series of stone ledges formed a stepped filtration system, trapping debris and allowing clearer water to settle at the bottom. Isotopic analysis of sediment layers indicates that the cistern was emptied and refilled at least 12 times per year, aligning with the region's bimodal precipitation pattern. The Mug House community, estimated at 80 to 100 individuals, relied on this cistern for drinking, cooking, and even ritual purification, highlighting the cultural importance of engineered water storage. Between 1275 and 1300 CE, the Southwest entered a prolonged megadrought, with tree-ring data showing a 30% drop in annual precipitation. Reservoir levels fell below 20% of capacity, and the intricate canal gates began to clog with sediment. Archaeological layers reveal a rapid abandonment. Hearths were left cold, pottery was broken, and water channels were deliberately sealed with packed earth. Yet the engineering concepts survived. Modern Pueblo descendants still use clay-lined catch basins, and contemporary water conservation projects in New Mexico reference the Pueblo's slope gradient calculations. A 2022 study by the American Society of Civil Engineers demonstrated that replicating the Pueblo reservoir design could increase water capture efficiency by 12% in arid regions today. The lost engineering of these cliff dwellings reminds us that sustainable water management is not a modern invention, but a timeless human necessity. Next time, we'll follow the water trails to the hidden aqueducts of the Maya. Subscribe now and travel with us into the engineering secrets of ancient civilizations.